Have you ever imagined a world where mosquitoes could save lives instead of being a nuisance and a health hazard? Scientists are currently transforming this into reality. Welcome to the promising realm of genetically modified mosquitoes. This is no sci-fi, but a sincere effort to combat diseases like Zika, dengue and yellow fever spread by mosquitoes, especially the Aedes aegypti species. To fight this, genetic modification is being explored. By altering the genes of these pests, the goal is to cut down their populations and thus disease spread. Oxitec has innovatively modified male mosquitoes to carry lethal genes. Their offspring with wild females inherit these lethal genes and die before reaching adulthood. Yet this is not simple. Genetic intervention is a complex process with potential risks. The world of genetically modified mosquitoes is a delicate balance of disease control promise and genetic modification risks. The journey to this groundbreaking innovation is as fascinating as the concept itself. Our journey begins with a problem: the need to control diseases spread by the Aedes aegypti mosquito. This tiny creature is the main vector for a host of deadly diseases, including Zika and dengue. Conventional pest control methods often led to unintended consequences. Thus, we faced a crossroad, needing to rethink our approach. Enter the world of genetic modification, where we could tweak the DNA of pests to control their population. British firm Oxitec proposed a revolutionary method: genetically modified male mosquitoes with lethal genes. These modified mosquitoes would mate with wild females, resulting in offspring that cannot survive. Field tests in Brazil led to an 82% decline in the mosquito population. However, the road to genetic modification was filled with scientific concerns and public resistance. Questions were raised about the effectiveness of Oxitec's technology. The path to genetic modification has not been smooth, but it has certainly been enlightening. Now, you might be wondering, how does one genetically modify a mosquito? The process initiates with identifying the genes impacting the mosquito's life cycle, mainly lethal ones that cause the death of the mosquito's offspring before adulthood. These genes are isolated using gene sequencing in a lab. The isolated genes are then modified in a way that the offspring using gene editing. This is like using molecular scissors to cut and paste DNA. The modified genes are introduced into male mosquitoes, which are released in the wild. Mating passes these lethal genes to the offspring, creating a new generation that cannot survive to adulthood. This method has resulted in an 82% decline in the mosquito population by turning biology against the mosquito. However, this process involves manipulating life's building blocks, presenting ethical and environmental implications. It's a marvel of science, but not without its fair share of controversy. Like any scientific breakthrough, genetic modification of mosquitoes has sparked intense debate. The crux of the argument lies in the potential to control disease-carrying insects, reshaping public health. Yet tampering with nature is fraught with uncertainties. Past biological control attempts have led to unforeseen consequences. Would genetically modifying mosquitoes do the same? The biotechnology firm Oxitec proposes a solution involving genetically modified male mosquitoes carrying lethal genes. Field tests have shown an 82% decline in the mosquito population. Yet, some scientists argue that this might not be enough to halt disease spread. Furthermore, public apprehension towards genetic modification, especially concerning living organisms, stirs unease. Ethical implications and potential ecological impacts are common concerns. The debate is ongoing, but the potential impact of this technology on humanity cannot be ignored. We must tread the delicate line between disease control and playing God with caution, transparency, and respect. So, what could this mean for us, for humanity? In essence, genetically modified mosquitoes could be the key to drastically reducing diseases like Zika and dengue fever. Scientists propose to control the mosquito population by tweaking their genes, specifically those of the Aedes aegypti, the main disease vector. The method involves releasing modified males carrying lethal genes into the wild. The offspring of these males and wild females often do not survive, leading to a possible decline in the mosquito population. This holds monumental health benefits, potentially lowering the number of people who fall ill each year and relieving strain on healthcare systems. But there are considerations like potential ecological consequences and the effectiveness of the technology. We need to tread carefully, continuing research and careful implementation. The potential benefits are vast, but the potential risks are equally significant. It's a brave new world we're stepping into, one where mosquitoes might just become our allies instead of our enemies.